Good afternoon. My name is Slobodan Chuk. This video is my Power Electronics Manifesto. In a few days, I will celebrate this September 2018 50 years in power electronics. I studied electrical engineering in Belgrade, then Yugoslavia, as a part of a golden 1966 generation in a nuclear engineering department. In 1968, 50 years ago, I took elective courses in control system, completely unaware that this was, in fact, the start of my 50 years in power electronics. At that time, the control systems entered a new era of modern control systems pioneered by Kalman and Bellman, with a new state space formulation and concepts of controllability and observability. As fate would have it, on February 29, 1972, I took direct charter flight to San Francisco paid by NASA to work on my master thesis, Stability Investigation of Spinning Skylab. Skylab eventually fell, but I'm still standing. As another stroke of luck, I was sent in March of 1974 paper by late Professor Middlebrook about modeling of the boost converter as some early satellites ran into stability problems. I stared at that simple circuit with just one transistor, one diode, one inductor and output capacitor and realized I had no idea how it operates, yet it performed magic. It could step up input DC voltage that no other circuit could. My decision was made right then and there to go to Caltech and study for doctorate degree under Professor Middlebrook. He started in 1970 second academic program in the United States in the new field named power conditioning. As this sounded too close to name air conditioning, it was rather quickly stabilized to current name of power electronics. During my 2 years of studies at Caltech, I discovered on April 1975 a new type of switching converter based for the first time on capacitive energy transfer in addition to inductive transfer of three other basic converters. I called the converter optimum topology converter and thereby coined the word topology. Professor Middlebrook shortly thereafter named it Chuk converter. In fact, it was this capacitive energy transfer and my previous background in control system which enabled me to formulate general method of analysis now called state space averaging as a second part of my doctorate thesis. Very early on, our power electronics group, PEG for short, at Caltech, focused on what I thought then and do so now are three cornerstones of power electronics: topologies, magnetics, and control. I consider them always of equal importance for this multidisciplinary field. Now I have added the fourth most critical missing part, new switching methods, which in fact become the most essential for further progress of power electronics. This is not that I in any way downgrade the importance of switching devices and enormous progress made with the latest wideband gap devices. However, they are the last step of practical implementation, completely dependent on the previous four cornerstones by optimizing their device design for best system technology. Yet, sadly, at present it is the other way around. Best devices are designed to meet the limitation of old and obsolete system technology. Now I hear that in the United States alone, there are at least 100 universities with programs in power electronics and often with 2 or 3 faculty. I have 3 of my doctorate students as professor at one such United States university and a dozen more elsewhere in the world. This year also marks, miraculously, the culmination of my invention streak, which started 10 years ago in 2008. In fact, this is a year that I discovered how to replace that amazing boost converter which baffled me in March 1974 with a power converter on a chip, which eliminates its bulky and power-limiting inductor. This approach then enables likewise replacement of the venerable buck and flyback converters. I do hope that in a year I celebrate 50 years in power electronics, I will open the door to a museum of history of power electronics where all 3 basic converters will have their well-deserved resting place. When I share this and other exciting discoveries I made this year with close friends and colleagues, I'm often asked, "How did you do this, Dr. Chuk?" I'm, of course, thrilled to answer, elementary, my friend. I started working on this 50 years ago. Not 40 years ago, just exactly 5 decades ago. In addition to research and invention in power electronics, my passion was always teaching and finding that unique, most logical explanation after which you can only say, obviously, how could it be otherwise? Hence my decision to celebrate my 5 decades in power electronics by offering this September 25th, 2018, my first ever Masterclass. I call it a Masterclass. I hope to have in this class dozens of my former doctorate students, now professor, along with their students and other faculty and students worldwide who would learn about a lot of new roads to explore. This should be truly an international celebration, having power electronics specialists coming from China, Europe, New Zealand, Middle East, and possibly from elsewhere in the world. Don't forget also the faculty coming from all over the world. Together, we will make 22nd century power electronics now. I hope to meet you all on September 25th at my master class celebrating my 5 decades in power electronics. Thank you very much. Appreciate it.